Welcome to lecture 3 of inverse Laplace transform of video lecture series of engineering mathematics 3. In previous lecture we have completed the property number 1, that is first shifting property. Now in this lecture we are going to study the second property, that is property second shifting property. Okay, now what is exactly the second shifting property? Let us see this. So let us take the basic of Laplace transform. So we have seen that if Laplace transform of f of t is equal to f of s and capital F of t is equal to f of t minus a for t is greater than a, and that is equal to 0 for t is less than a, right? Then Laplace transform of capital F of t is equal to e raised to minus as into f of s. Okay, so this property we have already studied, isn't it? So now therefore, and one more formula we have also studied, this is basic 1 and this is basic 2, that Laplace transform of f of t minus a into u of t minus a, that is Heaviside function, unit Heaviside function. Okay, in that we have studied this, and what we can write this, e raised to minus as into f of s. So this is also e raised to minus as into f of s, and this is also e raised to minus s into f of s. So that means if whenever there is in multiplication of f of s, whenever there is e raised to minus as or e raised to plus as, then in that case we have to use this particular second shifting property or unit Heaviside function. Both are same. So this is the basic that we have studied. Now let us see this particular in inverse Laplace transform. If Laplace inverse of f of s is equal to f of t, then Laplace inverse of e raised to minus as into f of s. Okay, that means whenever there is e raised to minus as in multiplication to f of s, then the answer to this particular question will be in the form of two answers, that is, one is f of t minus a, t is greater than a and is equal to 0 for t is less than a. Okay, isn't it? So now how we can write this as or another way of writing this answer is, or Laplace inverse of e raised to minus as into f of s, that is equal to f of t minus a into u of t minus a. So this also we can write. Okay, this also we can write. Now let us try to solve some numericals upon this, so that you can clearly understand what is meaning of this particular second shifting theorem property. So let us take example number 1. Okay, find Laplace inverse of e raised to minus as upon s raised to 5. Find Laplace inverse of e raised to minus as, or let us take this as 6s. Okay, 6s. Laplace inverse of e raised to minus 6s upon s raised to 5 we have to calculate. So definitely this is the example of second shifting property. By e raised to minus 6s we can easily understand this. So comparing with Laplace inverse of e raised to minus as into f of s, what we get here? So here we get value of f of s as 1 upon s raised to 5, isn't it? So once you get the value of f of s, then just find the Laplace inverse of this. So Laplace inverse of f of s, that is Laplace inverse of 1 upon s raised to 5, can be written as, that is equal to t raised to 4 upon 4 factorial, and that is nothing but t raised to 4 upon 24. So this is the f of t that we have got. Now next is okay, what we have got f of t here? f of t is t raised to 4 upon 24. Okay, now by using second shifting property, what we can write this? By using second shifting property, we can write this as Laplace inverse of e raised to minus 6s upon s raised to 5. This can be written as in the two forms, that is t minus 6, okay, t minus 6 raised to 4 for t is greater than or equal to 6, okay, and that is equal to 0 for t is less than 6. This is one way, this is one answer. And what is the second answer? Laplace inverse of e raised to minus 6s upon s raised to 5. This can be written as t minus 6 raised to 4 into u of t minus 6. Okay, so I think this is the better option. So t minus 6 raised to 4 into u of t minus 6, this is the answer. Okay, and we have to follow this answer. Now let us take another example. Let us take one more example for this. Okay, sorry, and sorry, here there is 24, so here also we have to divide it by 24. Okay, sorry, this mistake, there is one mistake like this, so remember this. Now let us take another example. Find Laplace inverse of 24 into e raised to minus 5s upon s minus 1 raised to 5. S minus 1 raised to 5. Now how to simplify this? Okay, simple. So comparing with Laplace inverse of e raised to minus as into f of s, what do we get here? Laplace inverse, sorry, here we get a is equal to 5 and f of s is equal to 24 upon s minus 1 raised to 5. So we can easily find the Laplace inverse of this particular function. So first, Laplace inverse of f of s is equal to Laplace inverse of 24 upon s minus 1 raised to 5. How to find this? So 24 can be taken outside, and this is first shifting property. So e raised to t into Laplace inverse of 1 upon s raised to 5, isn't it? So that is equal to 24 e raised to t into what is this? T raised to 4 upon 4 factorial, and that is equal to e raised to t into t raised to 4. 24 get cancel. Okay, 4 factorial is 24. So the value of f of t is e raised to t into t raised to 4. This is Laplace inverse of 24 upon s minus 1 raised to 5. Now by using second shifting property, we can write this as, that is equal to Laplace inverse of e raised to minus 5s, okay, into 24 upon s minus 1 raised to 5. So this can be written as what? E raised to t minus 5 into t minus 5 raised to 4 into u of t minus 5. So this is the simple answer. Okay, so now let us take another example. Okay, so find Laplace inverse of e raised to minus 2s into 4s plus 12 upon s square plus 8s plus 16. Now how to simplify this? That is equal to, first of all, comparing with Laplace inverse of e raised to minus as into f of s, we get f of s is equal to 4s plus 12 upon s square plus 8s plus 16, right? So first of all we have to find out Laplace inverse of this. So Laplace inverse of f of s is equal to Laplace inverse of 4s plus 12 upon s square plus 8s plus 16. Now that is equal to, now first of all we have to see whether this particular denominator is of perfect square or not. So I think it is a perfect square. So Laplace inverse of 4s plus 12 upon, this can be written as s plus 4 bracket square, s plus 4 bracket square, okay. But at the numerator there is no s plus 4, so we have to adjust it. How to adjust it? So Laplace inverse of 4 in bracket s plus 4, okay, minus 4 plus 12 divided by s plus 4 bracket square. So we have added and subtracted plus 4 and minus 4, okay, in the numerator. Now that is equal to Laplace inverse of, if you multiply by this 4 to this bracket, what we get here? 4 in bracket s plus 4 minus 4 4 is 16 plus 12 divided by s plus 4 bracket square. That is equal to Laplace inverse of 4 in bracket s plus 4 minus 4, okay, minus 16 plus 12, that will be minus 4 divided by s plus 4 bracket square. Now if you observe this, at each and every s there is s plus 4. So therefore by using first shifting property, we can write this as e raised to minus 4t, okay, in bracket Laplace inverse of, what we get here? 4s minus 4 upon s raised to 2, s raised to 2, sorry, this is s raised to 2, okay, because this plus 4 is, we have written in this particular e raised to minus 4t, so this 4 is removed and here we can write just s square. Now if you further simplify this, what we get? If you simplify this further, then this can be written as e raised to minus 4t as it is, Laplace inverse of, okay, Laplace inverse of 4s upon s square minus 4 upon s square. That is equal to e raised to minus 4t into Laplace inverse of, this s is cancelled, so this will be 4 upon s, okay, and here Laplace inverse of 4 upon s square, bracket close. Now that is equal to e raised to minus 4t in bracket 4 as it is, Laplace inverse of 1 by s is 1, minus 4 as it is, Laplace inverse of a square is t raised to 1 upon 1 factorial, that is 1, okay. So this is nothing but you can take 4 common, e raised to minus 4t minus e raised to minus 4t into t, bracket close. So this is what? F of t, small f of t, sorry. Now by using second shifting property, Laplace inverse of e raised to minus 2s into 4s plus 12 upon s square plus 8s plus 16, bracket close, that can be written as 4 into bracket e raised to minus 4 into t minus 2, okay, minus e raised to minus 4 in bracket t minus 2 into t minus 2 into u of t minus 2, bracket close. So in this way we have to write down this particular example, okay. Now let us take another example. Let us take one more example to understand it again carefully. Now one more thing, you can just, this particular thing can be simplified further, okay. If you simplify this, you will get some more simple way of this particular example answer. What? 4 e raised to minus 4 t minus 2 can be taken outside. What we get here? 1 minus, okay, t minus minus plus 2 into u of t minus 2. Okay, and again this can be written as 4 e raised to minus 4t minus 2 into 2 plus 1, that will be 3. Okay, and that is nothing but 3 minus t into u of t minus 2. This also we can write. Okay, so this is the simple form. Now let us take example number 4. Find Laplace inverse of e raised to minus pi s upon a square plus 2s plus 2. Okay, now same comparing with Laplace inverse of e raised to minus as into f of s. What we get here? Value of f of s that we have got here is 1 upon a square plus 2s plus 2. Okay, so just take Laplace inverse of this. So Laplace inverse of f of s is equal to Laplace inverse of 1 upon a square plus 2s plus 2. Now this is not a perfect square, so first of all we have to make this perfect square, and for that we require the value of third term. So third term is equal to coefficient of middle term bracket square divided by 4 into coefficient of first term. So coefficient of middle term is 2 bracket square upon 4 into 1, that is 4 by 4, that will be 1. So therefore Laplace inverse of 1 upon a square plus 2s plus 2 can be written as Laplace inverse of 1 upon a square plus 2s plus this third term is 1 minus 1 plus 2, that is equal to Laplace inverse of this is s plus 1 bracket square plus 1. Okay, now this we can solve by using first shifting property. So by using first shifting property, e raised to minus t Laplace inverse of 1 upon a square plus 1, e raised to minus t into what is this? This is sin t. Okay, now by using second shifting property, this can be written as Laplace inverse of e raised to minus pi s into 1 upon a square plus 2s plus 2, that is equal to e raised to minus in bracket t minus pi into sin of t minus pi into u of t minus pi. Okay, and this is the final answer. Okay, now let us take some examples for homework. You try to solve that examples at homework. Okay, example number 5. Find Laplace inverse of s into e raised to minus 2s upon a square plus 25. Very simple question. 6. Find Laplace inverse of s into e raised to minus 3s upon s square minus 1. Again very simple question. Next question. Find Laplace inverse of e raised to minus pi s upon s square plus 9. Okay, such type of examples will be asked in the objective type examination. Very simple questions. 1 step, 2 step answers are there. Now find Laplace inverse of e raised to minus 2s upon s minus 5 raised to 6. So again this is very simple question, isn't it? Example number 9, you can take example number 9 for homework. find Laplace inverse of e raised to minus 2s upon a square plus 2s plus 10. Find Laplace inverse of e raised to minus 2s upon a square minus 6s plus 25. Find Laplace inverse of e raised to minus 2s upon 2s plus 1 bracket square. And last example, you can take this. Find Laplace inverse of e raised to minus 2s upon s plus 3 bracket square minus 4. Simple question. Okay, so try to solve these examples at home. Okay, so I hope you understand the second shifting property, and in next lecture we will see the next property. Okay, thank you very much.